Hello. Okay, today we're going to talk about systems of equations again, but this time we're going to throw quadratics in the mix. Okay, so there's essentially three different outcomes because we're going to look at linear and quadratic. We could do quadratic and quadratic, but let's not be too crazy. So today we're going to look at linear, which is a straight line, mixed with quadratic. So there's three outcomes we could have in this. We could have, let me show you. Okay, here's my linear. I'm going to draw the same linear line on all three of these options. So we can have a system that has no solution, right? Like we could have a parabola that just can't cross with our linear line. So in this case, there's no solution, right? So no solution is definitely an option in these. It's not so much an option nearly as often with two linear lines. Linear lines are bound to cross somewhere unless they're parallel. So, but no solution's like a very real possibility with these. We could also have one solution if our parabola and our linear line just kind of like barely touch and graze each other. We can have one solution, or we can have two solutions, right? Because these would cross, they would intersect in two places. So this is a little bit different. We're still going to use our same three methods. And our same three methods, are substitution, elimination, and graphing. So those aren't going to change. They're going to look a little bit different because we're going to have an x squared. But what's really going to change is that it's possible to have no solution, one solution, which we're used to, or now two solutions. So let's take a look and see what that looks like. So we're going to use one system, and we're going to use it for elimination and for substitution. So we're going to have 5x minus y equals 10. Can you see that? And then we're going to have x squared plus x minus 2y equals 0. So if you notice, these are set up so x and y are on the left side of both equal signs, and we can do whatever we want with that. So, okay, so here's going to be our system, and we're going to do this in two ways. We're going to start with substitution. Did I spell that right? Yes. Okay, so if we start with substitution, we're going to have 5x minus y equals 10. And then we have x squared plus x minus 2y equals 0. So in substitution, we need to get something alone. So I'm gonna choose to rearrange this because that y is already by itself. So I'm gonna rewrite this, and I'm gonna solve for y. So that's going to give me negative y equals negative 5x plus 10. I'm going to move out my negative, so I'm going to have y equals 5x minus 10. Okay, now I'm going to take that and I'm going to plug it in right here to my y. So that's going to give me x squared plus x minus 2y. Well, y is 5x minus 10 equals 0. So I'm going to work this out. I'm going to have x squared plus x minus 10x, because I need to distribute, plus 20 equals 0. Now, what we have here is a quadratic function. So we're going to combine like terms, and then as long as this equals 0, we can factor it and solve for x, right? So this is really x squared, minus 9x plus 20 equals 0. So if I factor that, I get x, minus 5 times x minus 4 equals 0. That means that I've got x equals 5 and x equals 4. Okay, so this potentially has two solutions. Okay, so that's good. Now, I can plug those both in and find my y. And if I do that, sorry, I'm making this even smaller. If I do that, I'm going to have 5 times 5 minus y equals 10. So 25 plus 10 is 35. Y equals negative 35. Nope, that's not right. Y equals, let's see, 10 minus 25 is 15. Okay, 15. Y equals 15. So therefore, that answer is 5, 15 is the solution. And if I do the same thing with my 4, I plug my 4 in. So I'm going to have 5 times 4 minus y equals 10. So minus 20 minus 10, y equals 10. Is that right? Yeah, and then I would have 410 as a solution. Okay, so I did this using substitution, and I got two solutions. And the reason I got two solutions is because when I substituted in for y, I had a quadratic, and then I factored my quadratic because it was equal to 0. Remember, it has to be equal to 0 if you're going to factor. And that's where I got two x's. Then I plugged each x in individually to find its y. So I got two solutions. Okay, now, if I want to do this with elimination, so we're going to do the same problem again with elimination just to prove to you that you can. Now remember, we said you have to stack this stuff. So if I stack this, I'm going to have 5x minus y equals 10. So that means when I go to stack this, I need the x to be under the x and the y to be under the y. That means this x squared is going to kind of chill off to the side because this one doesn't have an x squared. So I'm going to set my x squared off by itself so I can line up my x and y and my constant. See what I mean? Okay, now remember when you do elimination, you have to have matching coefficients somewhere, which I don't have. So I think my best bet is to get the y coefficients to match. So I'm going to multiply this whole y by 2. So I'm going to multiply this whole thing by 2. And that's going to give me, I'm going to rewrite. So I'm going to then have 10x minus 2y equals 10. And I'm going to rewrite my next one so I don't mess myself up, because organization is the name of the game in this kind of problem, right? You have to be really careful. Okay, so we're going to subtract the whole thing. Now, remember, this is like saying 0x squared here, right? Like, couldn't I really write that in if I wanted to? And if I did that, 0x squared minus x squared is, negative x squared. So negative x squared. And then I have 10x minus x, so 9x. My 2y is gone because negative 2y plus 2 is nothing, equals 10 minus 0 is 10. Okay. Oh, hey, I goofed. That's 20, isn't it? Man, my subtraction, I forgot to multiply back here, my 2 times my 10, 20. Okay, remember what we just said. You can't factor a quadratic unless it equals 0. So that means I need this 20 to move over. So I'm going to do some rearranging here. Then I'm going to get negative x squared plus 9x minus 20 equals 0. And then I'd like to factor this thing, but I can't factor with that negative in there, so I'm going to factor it out, and then I'm going to get x squared minus 9x plus 20 equals 0. Okay, so now can I factor? Yes. And I'm going to get x minus 5 times x minus 4. And I've got this negative out front because I know this whole thing's going to face upside down, and that's fine. and that equals 0. So again, where's my x? My x's are going to be 5 and 4, which is what I got over here. So I could go ahead and plug the y's in right now, and I would get the same thing as I had earlier. So I think you know how to do that step. But you can see that substitution and elimination are going to get you to the same place. So you can choose whichever one you'd like to do. Just remember that when you set up your elimination, your x squared is going to be off on its own. It doesn't stack with the x and the y's because you have to stack with like terms. Okay? When you go to factor, it has to equal 0. Factoring and solving for x only works if you equal 0, so be real careful of that. Okay, let's try one more just to make sure we've got it. And I think we'll do this one with elimination because elimination's generally more tricky on this. So 3x plus y equals -9. And 4x squared minus x plus y equals -9. All right, if we are going to use elimination, we're going to stack them up. So I'm going to say 3x plus y equals -9. And then I'm going to put my 4x squared out here, minus x plus y equals -9. Well, this is just convenient because look, I already have my y's that are the same. So it's your lucky day. So we're going to subtract this whole thing, and we're going to get -4x squared. 3x minus -x is 4x. Y minus y is 0. -9 minus -9 is 0, right? Okay, so this one is a quadratic. It has an x squared, but I'm not going to factor this using the same method of factoring. And all I can do here is take out a common factor. So I'm going to take out a -4x because they have that in common. And that's going to leave me x minus 1 equals 0. And remember, I was able to do that because I was already at 0. Okay, if we divide this up, we have -4x equals 0 and x minus 1 equals 0. So therefore I know x is going to be 0 and x is going to be 1. I'm going to come plug those back in. And if I plug them in, I'm going to choose 3x plus y equals -9. So I'm going to do that 2 times. So I'm going to say 3x is 0 plus y equals -9. Therefore, y equals -9. And my solution is 0, -9. And then I'm going to do that a second time with 1. So 3 times 1 plus y equals -9. So 3 plus y equals -9, and y equals -12. So that solution is going to be, 1, -12. And there's our 2. So again, in this one, we have 2 solutions again. Okay? That's all there is to it. Graphing is pretty straightforward. If you wanted to graph, you need to rearrange. So let me show you what that looks like. Like, let's say we had, Let's say we had x squared minus x minus y equals 6. And then we had, 2x minus 2 equals y. So if we had these, what we would need to do is get out our graph. Okay, good, let's use a real graph. And we can go ahead and graph this linear line, right? So I'm going to have a y-intercept at -2, a slope of 2 over 1. It's positive, so it's going to do something like this. Okay. And then you need to deal with this, and it's not really written in the format we like. I really prefer my y to be alone. So if I rearrange that, I get y equals x squared minus x minus 6. And then you can factor, right? So x, let's see, plus 2 times x minus 3. And that tells me my x-intercepts are at 3 and negative 2. And then I could find my, let's see, my vertex is going to be 1, 2, 3, 4, 5. My vertex is going to be like here, and then probably down here. And then we can graph this, right? And we can start to really find where our points of intersection are going to be. So graphing works. It's much better if you're given the graph and look for the solution. But if you want really specific numbers, your best bet is going to be substitution or elimination. Okay, that's all there is to it. Good luck.